Hello guys, welcome to our YouTube channel once again. Today, I would like to take you guys through the Newton's laws of motion. But before we get started, please guys, subscribe to my YouTube channel for more videos. Please let's get started. The Newton's laws of motion was discovered by a scientist called Sir Isaac Newton. Sir Isaac Newton was a scientist who worked a lot in the study of physics. Thereby, he brought about the three laws of motion, and we call it the Newton's laws of motion. So guys, let's get started. Okay, guys, in the Newton's laws of motion, he brought about three laws of motion. They are the first law of motion, the second law of motion, and the third law of motion. Listen, let's go. The first law of motion states that if no external force or if no net force is applied on a body and the body remains still, the body will continue to be in the state of rest or be in a state of uniform motion in a straight line. Let's take it again. It states that if no external force or net force is applied on a body, the body will continue to be in a state of rest or to be in a state of uniform motion in a straight line. What does this mean? It tells us that assuming I place a ball on a table right now, when I don't apply a force on it, the ball will remain on the table till eternity. Or now, when I set a ball rolling on a table, if there is no external force applied on it, the ball will continue to roll and roll till it continues. That is the Newton's first law of motion. Okay, let's continue. The Newton's first law of motion is also called inertia. There's something called inertia. When I talk of inertia, inertia is the reluctance of a body or the stubbornness of a body to remain at rest or to remain in a continuous motion when a force is applied to it. So now, what it means is that when a ball is lying down, the ball has a resistance or a reluctance to move when you go and apply a force to it. Or when a body is moving or is in the state of motion and you are trying to stop it, the body will resist your stoppage or the force you apply to it, it will resist to it. So let's continue. Also called inertia. Okay, so listen, there are various examples I can give that can testify to the fact that the Newton first law of motion exists. So listen, assuming now someone sits on a chair, assuming the passenger is sitting in a car and the car starts to move, the person jerks backwards because the person wants to be in a state of rest. And assuming a passenger in a moving car, when the driver applies the brake, the passenger jerks forward. That means that the person in the moving car will continue to be in a state of motion. So the Newton's first law of motion has been applied. Okay, let's continue. There are various factors that affect the first law of motion, that is the inertia. There are about 3 factors that can affect it. One is the mass of the body. So now, the bigger the mass of the body, the higher the inertia. Or the bigger the mass of the body, the greater is inertia. The mass is talking of the quantity of matter in the body. So the heavier the object, that means the more is inertia, or the more is reluctance to stop or to move when you apply a force on it. That means the mass of a body is directly proportional to the inertia of the body. Okay, there's a second factor called the speed. The speed of the body really plays a key role in it. So now, assuming a body is moving at a fast rate, or a body is speeding and you try to stop it, that means that the body will take a longer time to stop. Or assuming a body is moving at a slow rate and you try to stop it with the same force, the body moving with a lower pace will stop as faster as possible as compared to the other one. So speed is another factor that can affect the inertia of a body. The third one is the kinetic energy. So now, since speed has come into the case, that means kinetic energy must also come. The kinetic energy is about the energy possessed in the moving body. That means the higher the speed of the thing, that means the higher the kinetic energy of the body. So that means that all these factors I've listed here are directly proportional to the inertia of a body. Let's continue. But hello guys, before we continue, don't forget to subscribe to my YouTube channel for more videos. So this takes us to a next level called the second law of motion. Now let's consider a body that is being applied by a force, or 2 forces, or 3 or more forces. What happens then? This brings us to Newton's second law of motion. Let's go. What does this law say? This law says that the time rate of change of momentum of a body is directly proportional to the force applied on it, and it takes place in the direction of the force. It might seem so complicated. Let me take it again. The time rate of change of momentum of a body is directly proportional to the force applied to it, and it takes place in the direction of the force. So now, assuming a body is at rest, when I change the momentum of the body by applying a force on it, that means that the body must move in the direction of where the force has been applied to it. That is all about the Newton's second law of motion. And there are examples that can testify to the fact that the Newton law's second law of motion has really applied in each case. So this one is the mathematical expression for the second law of motion. Okay, so these are the examples that can testify to the fact that the Newton's third law of motion really exists. So now, consider a car moving at a very high velocity. The car is moving at a very fast rate. So now, when the car goes and gets, let me say, an accident or hits a stationary wall, and the car stops immediately, you realize that the car will sustain more damages because the time taken for the car to stop is very small. That means the car will attain more damages. And assuming now the car moves at a slower pace and goes and hits a stationary wall, the car does not sustain more damages because the time taken for the car to stop has been extended. That means the higher the time taken, the lower the damages sustained. But the smaller the time taken, the higher the damages sustained. And let's consider two people at the same height, and both of them are coming to land at the same place. One is going to land on the bare floor, and the other is going to land on a cushion. So now, the person landing on the bare floor will sustain more injuries because the time taken for that person to land on the floor is very small and limited. But with a cushion, the person landing on the cushion will not sustain more injuries or serious injuries as compared to the other one because his time has been extended. So this brings us to the end of Newton's second law of motion. So let's go to the third law of motion. But don't forget to subscribe to my YouTube channel for more videos. Let's continue. Okay, guys, Newton's third law of motion is one of the simplest and the easiest you can know. It states that actions and reactions are the same but in the opposite direction. Don't worry, I'll explain it to you. Okay, like I said, this is one of the simplest law of Newton. So now let me explain it to you. Assuming now body A, let me say a body A exerts a force, let me say a body A, let me say exerts a force or applies a force on a body called body B. Okay, so now the force in which body A has been applied to body B, it states that this is called the action, and they are saying that body B will also exert the same amount of force on body A but in the opposite direction. Just like as this one is going to here, this one is also bringing it back. Okay, and there are more examples I testify to the fact that Newton's third law of motion really exists. Okay, Let's consider a swimmer in a water pool. So now the swimmer exerts a force backwards on the water, and the water also exerts the same amount of force on the swimmer, making the person to propel forward and forward. That is how the Newton's third law of motion works. Let's continue. Let's consider the work of the rockets. Rockets are sent to space for, let me say, spacecraft and scientific exploration. So now, in a rocket has fuels, burning gases, which burn out like hot gases. So now, when a rocket has been set to go to space, the rocket exerts hot and strong gases at its nozzle. So now, the same amount of force exerted by the gases is also exerted on the rocket to propel it to move up and higher and higher. And finally, it goes to space. So this brings us to the end of the lesson, the Newton's laws of motion. But don't forget to subscribe to my YouTube channel for more videos. But don't also forget, you can ask your questions. I'll answer them in the immediate videos to come. Don't forget. Thank you so much for watching. Have a nice day.